Imagine standing at the base of just a massive skyscraper, right? Or maybe looking across one of those huge, complex bridges spanning some vast canyon. Before the first bit of concrete gets poured or, a single steel beam is even set, there's this huge question just hanging there. How much is this actually going to cost? I mean, we're basically talking about predicting the future, aren't we? Down to the very last bolt and brick, welcome to the deep dive. We're the show that unpacks the hidden complexities behind, well, the everyday wonders all around us. Today, we're really plunging in deep. We're going into the world of construction estimating. It's this really intricate blend of art and like precise science, all focused on forecasting the financial side of these huge projects. And for you, our listener, our mission today is to really pull back the curtain, explore exactly what goes into creating that crucial budget. Think of the estimator as kind of the financial gatekeeper for any construction project. They're the bro who has to blend data, years of experience, and really sharp judgment. That's what lays the foundation for financial success. We're going to uncover how they handle everything, from those really early rough estimates.
Back of the envelope stuff.
Exactly. All the way to that super high stakes, like last minute chaos of the midday scramble. Okay, let's unpack this role. It's clearly fascinating and so important. It's not just about crunching numbers, is it?
Not at all.
It's about understanding this whole universe of factors. I mean, from the tiny detail of a window frame up to, like, the big picture of urban planning.
Yeah, and what's really captivating, I think, is how this role has to synthesize so much diverse information. You've got engineering, economics, logistics, even, like you said, planning. It's this real blend of the analytical, the number side, and the intuitive, the gut feeling based on experience. And they have to be constantly adapting, right, to new tech, changing markets, what the client wants. It's not just a job. It feels like a constant intellectual puzzle, which it makes you ask, okay, if we strip it all back, what exactly does an estimator fundamentally do? What's their main purpose?
Right.
The foundation of foresight, defining construction, estimating.
Yeah, that's the perfect place to start. Because before a single shovel hits the dirt, right,
Yeah.
before any heavy machinery even shows up, someone has to look into the future and predict the cost, down to the last dollar, ideally. So this deep dive, it's really a profile of that professional, the construction estimator. Their foresight is just, well, fundamental.
It really is. And, the essence of it is captured pretty well by what project management folks call the predictive approach. And it's foundational because this is where the big things, the project scope, like what exactly are we building, the timeline, how long will it take, and crucially, the cost. All that gets determined really early in the project's life cycle.
Okay.
And it's not guesswork. It's calculated. It's informed. It establishes the financial blueprint, you could say, like a really detailed map for the money side of things.
Right.
Without that, you're kind of lost at sea, financially speaking.
Yeah, I can see that.
I mean, just to put it in perspective for you, our listener, imagine trying to build your dream house, right? Without any clear idea of the total expense.
Oh, nightmare. Total nightmare.
Exactly. And that's the estimator's challenge, but just on this massive scale. Projects worth millions, hundreds of millions, sometimes billions, they're the ones looking ahead, seeing potential costs, anticipating hiccups, modeling the finances long before anyone breaks ground. Their accuracy, it literally sets the stage.
Okay, so once we get that core purpose, the next logical thing is, well, where does this estimating actually fit in the whole process? From the first idea to cutting the ribbon, it must slot in somewhere really specific, a critical point in the timeline, right?
Oh, absolutely central. It's right there in what's called the pre-construction stage. Sometimes people just call it job startup.
Job startup, okay.
And this isn't just, a quick preliminary step. It's this dedicated, intense period for planning, charting the course, assembling the team engineers, architects, key subcontractors. Our source material really hammers this home. It stresses how important this step is. It can literally set you up for success or, total failure. Without a really well thought out, thoroughly estimated plan at this stage, the whole project is just built on shaky ground financially and logistically.
Right. It's where you catch problems on paper first.
Exactly, before they become expensive problems out on the site.
Okay, but here's where it gets really interesting and maybe a bit stressful just thinking about it. Our sources also say sometimes this pre-construction phase is, quote, fast and furious. Because of tight schedules, right?
Yeah.
So finding the time to do that really thorough plan sounds incredibly difficult under that kind of pressure. That must add a whole layer of stress.
Oh, it absolutely does. That's a very common reality in construction. But, that pressure actually highlights just how critical it is to come up with a robust, a truly workable scheme of operations during that planning phase. Project management texts talk about needing an intimate knowledge of the project.
Intimate knowledge.
Yep. Yeah, it means the estimator can't just skim the surface. They can't just use generic numbers. They need to deeply understand everything. The site conditions, local labor costs, material lead times, potential permit hurdles, even like the client's unspoken priorities. So it's not just about working fast, it's about making really informed, precise decisions quickly under the gun to make sure that initial plan, even with the time crunch, is as solid and realistic as possible. It really speaks to their expertise.
Okay, so every project manager seems like they know this constant battle, right?
Okay.
Balancing cost, time, and scope. The old cost, time, scope triangle.
Yeah.
Because if you pull one corner, the other two get affected.
Yeah.
How does estimating fit into that? How does it influence this delicate balance?
Yeah, the cost time scope triangle is like project management 101, isn't it? It just clearly shows how those three things are totally interdependent. You decide to expand the scope, maybe add fancier finishes or more tech,
Right.
or you decide to shorten the time, demand a faster build. Well, that's going to directly, invariably push the cost up. You just can't change one without impacting the others.
Makes sense.
Estimating provides that crucial starting data for making those trade-offs. It's the numbers behind the triangle. The estimator puts the actual figures to each side of that equation, and that lets the project managers, the owners, make informed choices, like where should we invest more, where can we find savings, where do we need to compromise, and they know the financial consequences before they make the call.
They quantify the trade-offs.
Got it?
2, the science of numbers. Types of estimates and their detailed breakdowns. So when most of us hear estimate, we probably just think of one number, right? Like the final price tag. But our sources show this really interesting progression. It's like zooming in, isn't it? From broad strokes down to incredibly fine detail. It's definitely not a one-shot deal.
You're spot on. It's not static at all. It's dynamic. It's iterative. In those very early design phases, when maybe you just have sketches, information is limited. That's when you're doing those rough order of magnitude estimates, high-level forecasts, maybe based on cost per square foot or similar past projects.
Just to see if it's even feasible.
Exactly. Is it worth even going further? But then, as the design gets more solid, the architectural plans firm up, engineering details come in, the specs get really precise, then the estimating process shifts gears. You move toward much more detailed unit price estimates. And those are absolutely essential for putting together that final competitive bid a contractor submits.
Okay.
So this evolution, it allows for constant refinement. The numbers get more and more accurate as more info becomes available. Even historically, think about military architecture back in 9th, 10th century France. The sources mention hundreds of earthworks and forts were built everywhere. Even back then, figuring out the great expense of building new walls, well, that needed some kind of estimating. Maybe it started super basic, big fort costs more than small fort.
Right.
But as designs got more common, you'd get rudimentary unit price ideas emerging, like how many workers and how much stone do we need for, say, 1 meter of wall? It's just a fundamental need to quantify effort and materials.
That makes total sense. So with all these details changing and these projects being potentially huge and complex, how do estimators make sure they don't miss anything? Anything crucial? Sounds like you need a really systematic way to break it all down.
Oh, absolutely. And the tool they use is fundamental. It's called the work breakdown structure, or WBS.
WBS, okay.
And it's not just a list. It's this hierarchical, methodical way of taking the entire project scope and breaking it down into manageable, identifiable chunks, work elements, or building blocks that define exactly what needs doing. Think of it like taking apart a really complicated engine piece by piece and tagging every single part.
Yep.
So, for example, our source material gives a great illustration. A WBS might start by breaking down the whole building into big categories: foundation, structural frame, site work. But it doesn't stop there. Foundation gets broken down further into specifics like pile cap, piling, excavation. And even within something seemingly straightforward like concrete for the foundation, you'd break that down into distinct tasks: pouring the concrete, installing the rebar, building the forms, the actual placement, preparing shop drawings for custom bits, cutting and fabricating the rebar, delivering materials.
Oh, that's granular.
It has to be. That level of detail is crucial because it lets the estimator systematically count and cost every single task, every single material. It prevents stuff from getting missed and leads to a much more accurate budget. It's really the backbone of a reliable estimate.
So that means looking at literally every single thing, From the biggest beams holding the building up down to the smallest finishing touches, like, I don't know, the hinges on a door. Is that detailed?
Pretty much, yes. The level of detail can be astonishing. And our sources have some fantastic examples, like for wood stud framing. An estimator doesn't just guess a lump sum for lumber. No, they account for the exact sizes and spacing, say 2x3 studs placed at 16 inches on center for walls that aren't load-bearing.
Okay.
That 16 inches on center, it's not random. It's standard for strength and for attaching drywall properly. They count double-end joists where floors meet walls, specific joist spacing 12, 16, 24 inches apart depending on the load. Headers over windows and doors, like 2x4s for a 4-foot span supporting just a roof. Trimmer studs, rough sills, cripple studs around openings, all counted.
Mm.
They'd even factor in the exact type of sheathing, like APA-rated plywood or maybe OSB panels over the rafters, and ventilation for roof spaces to stop moisture buildup.
It's not just listing materials, is it? It's understanding how every choice affects strength, stability, safety, and cost.
Precisely. It's a microscopic view, but it has these huge macroscopic consequences for the whole project.
To give you, our listener, a kind of relatable picture here, think about the windows in your own place. Maybe you have a casement window that cranks out, or an awning window that pushes up, or a hopper window that tilts in. Each one is different, right? Specific sashes, hinges, tracks, different ways to install them. An estimator has to count and cost all those unique bits and the labor for each type, not just put down windows as one item. The cost difference can be pretty big.
And it's definitely not just wood. Take a foundation wall. The estimator looks at the structural bits, like the reinforcing bars, rebar. Where does it go? Top and bottom. Especially crucial if the soil isn't great, because that can cause stresses the concrete alone can't handle.
Right. Prevent cracking.
Exactly. And for the concrete itself, they consider things like the water-to-cement ratio that's key for strength, using special admixtures like air entraining agents to help with freeze-thaw cycles, or water reducers to make it flow better without adding too much water. These aren't just fancy add-ons. They affect workability, long-term durability, and resistance to weather, which all impacts the cost and performance. They even need to know, is the concrete coming from a central batch plant, where it's precisely mixed? Or is it mixed on site, maybe by rule of thumb? That affects quality, consistency, and cost, too.
So it really boils down to knowing not just what goes into the building, but the detailed how.
Yeah.
How it all gets put together, right down to the finished plumbing, installing the toilets, sinks, faucets you actually see, connecting them perfectly to the pipes hidden in the walls. That's a different skill, different materials, different cost again.
Absolutely. The how is often just as critical as the what. It ties directly to labor hours, specialized tools needed, and the quality of the final outcome. Every single step, every connection, every finish has cost implications that need careful accounting.
Okay, so beyond just the sheer amount of materials and how they're assembled, what other, let's say, scientific requirements or external rules influence the final cost? Things that aren't just about building, but about regulations and performance.
Well, building codes are massive, absolutely paramount. They aren't optional suggestions, they're legal requirements. And they directly shape the design, the construction methods, and therefore the cost.
Right.
Estimators have to account for the building's occupancy classification. Is it a house, an office, a factory? That dictates critical things like how high it can be, how big an area, how many exits, and crucially, what fire protection systems are needed. For instance, automatic sprinklers are often mandatory for occupied floors above a certain height, maybe 55 feet above where the fire department can access. That adds a significant, unavoidable cost to taller buildings. They also have to factor in protecting structural parts, like ensuring fire resistance ratings for columns and load-bearing walls. That might mean special coatings or encasing them in fireproof material. These are non-negotiable safety standards, and they translate directly into material and labor costs.
So a project isn't just designed for looks or even just pure function. It has to tick this huge checklist of safety and performance standards. It's a really rigorous framework, and every single item on that list impacts the budget.
Absolutely, and that's a critical point. What's interesting is how sometimes those strict standards can actually push designers and estimators to find innovative, maybe even more cost-effective ways to meet them. And beyond safety, even things like daylighting design need careful thought. Getting lots of natural light is great for people inside and can save energy, right?
Sure.
But it has cost implications, too. Estimators need to factor in things like daylight sensors to dim the artificial lights automatically, and also the potential for extra heating or cooling needed if you have too much glass, which could increase running costs later.
Yeah.
These aren't just design preferences, they're performance factors that have to be quantified in the budget.
Yeah, it shows you, our listener, how every single line on a blueprint and really every sentence in those thick building code books eventually turns into a specific line item with a specific cost on that final estimate. It's quite something. 3. Tools of the trade. The digital revolution in estimating. Okay, the complexity here is just staggering. All these materials, codes, tiny details, the sheer amount of information. It really feels like it demands more than just, manual calculations and piles of spreadsheets anymore.
Yeah.
What are the key digital tools that are really changing the game for construction estimating? How are they managing all this?
Well, right at the forefront, the big one is building information modeling, or BIM.
BIM. Okay. Heard that term a lot.
Yeah, and it's a real game changer because it's way beyond traditional CAD, computer-aided design, which mostly gives you 2D drawings.
Yeah.
BIM is about creating an intelligent model. And in this model, the components aren't just shapes in space. They are linked to data describing what they are, their properties, how they relate to other parts. So like a wall in a BIM model isn't just lines. It knows it's a wall. It knows it's made of concrete or drywall or whatever. It knows its fire rating, its insulation value. It knows it's connected to that window or that structural column. It's this rich, living digital environment.
Oh, okay. That's a huge step up. So it's not just a drawing. It's more like a dynamic database, a digital twin of the building you can work with before you even start building the real thing.
Precisely. BIM software lets you build these models using parametric objects. These aren't just static shapes, they're intelligent components. They can automatically spit out consistent drawings and reports of dimensions and quantities. And even cooler, these objects can have rules built in. Rules that flag you if a change violates feasibility, like say, you try to make a door too wide for the wall it's in, or specify a beam that's too small for the load.
It catches errors automatically.
It can, yes, before they happen on site, which saves massive amounts of time and money fixing mistakes. And the data integration is huge too. BIM can send out sets of attributes like structural materials, acoustic data, energy performance data to other software.
Like estimating software.
Exactly, or scheduling programs. This smooth transfer of detailed quantity and other component information is vital for keeping costs and schedules under control. It gives you an accurate, almost real-time picture. You can even visually track progress against the model.
That level of foresight and integration sounds like it could prevent a ton of headaches. Like, the classic problem of finding out a plumbing pipe is supposed to go right through a main beam. Does BIM catch that?
That is exactly where BIM's design coordination features really shine. There are tools like Autodesk Navisworks Manage is one example, designed specifically to bring together models from different teams, architectural, structural, mechanical, electrical, plumbing, into one combined or federated model. And then it can automatically run checks to identify physical clashes. Finding exactly those conflicts, a duct hitting a pipe hitting a beam.
Before it happens in reality.
Yes. Detecting those conflicts super early in design prevents incredibly costly rework and delays during installation. It makes the whole construction process leaner, more predictable, less interrupted. It's a massive economic plus.
Okay, so beyond the models themselves, how do estimators tap into all the existing information out there? Like historical costs from old projects or detailed material prices, they need more than just the current project data, right?
Oh, absolutely. They rely heavily on historical cost databases and specialized software. Our sources don't name specific brands, but the idea of using that detailed quantity and other component information linked to other applications for accounting, procurement, that points strongly to leveraging huge amounts of structured cost data. Databases like RSMeans is a well-known one in North America provide benchmarks, material costs, labor rates, equipment rental, all based on location and past projects. This pushes estimating much closer to a true science because it's grounded in actual historical data, not just educated guesses. And the science part also involves really understanding the engineering. Estimators might not do the complex calculations themselves, but they need to grasp the implications, like knowing the span limits for steel beams based on deflection, how much it bends.
Right, because too much bend is bad, even if it doesn't break.
Exactly. It can crack finishes, make floors feel bouncy, just cause problems, or understanding loads on eccentrically loaded beams where the load isn't centered, which might need extra internal braces, stiffeners, to stop the beam side, the web, from buckling.
Okay.
It demands this implicit grasp of often complex engineering concepts to make sure the structure is sound and therefore the material quantities and costs are right.
That's fascinating. It sounds like modern estimating isn't just about the upfront cost, the first cost to build it. It's also looking at the long-term value, the running costs, even the environmental side. It's a much bigger economic picture, isn't it?
Absolutely. And particularly for high-performance green buildings, life cycle costing is the key tool for justifying decisions. This is a really important shift away from just looking at the initial price tag. Early studies on LEED certified projects, for example, suggested the added costs were about 2% maybe for silver or gold certification compared to a standard building.
Okay, not huge.
Right. But then the total 20-year savings are on the order of $50 to almost $70 per square foot for maybe an initial extra investment of like $4 a square foot.
Oh, that's a big return.
Huge savings coming from lower energy and water use, less maintenance, even better productivity from the people working inside. Some studies even found a 1-year simple payback when you factor in all the benefits: energy, water, emissions, health, productivity. It just completely changes the focus from what's it cost to build to what's it cost to own and operate over decades, which is, a much more meaningful number for the owner.
So what might look like a slightly higher first cost in the estimate, maybe that 2% extra for green features, can actually lead to really significant real savings and value for the owner over the long haul, making that initial investment look pretty smart.
Precisely. And this long-term view gets into specifics the estimator has to analyze, like high-efficiency fixtures for saving water, ultra-low-flow urinals using half a gallon per flush instead of the standard 1 gallon, or even waterless urinals. The slightly higher price for those fixtures gets paid back pretty quickly in lower water bills. Or think about smart buildings with integrated energy management systems controlling HVAC, lights, security. Those can generate substantial energy savings, maybe 10% of the building's energy use, just by optimizing everything in real time.
Right.
So the estimator has to look way beyond just the cost of the parts and the labor to install them. They need to consider the operating costs, the maintenance, the utility savings over the entire life of the building. It's a much more holistic financial analysis.
Okay, our world is just getting more and more connected, right? Real-time data streaming from sensors everywhere. What does that mean for construction, and specifically for estimators? How's this data explosion going to shape their work?
It definitely points towards an even more integrated, data-soaked future. As we move towards smart cities, our sources talk about urban life playing out where physical and digital space converge. We're already seeing new tools emerging that connect people, let them take an active role. Like those 311 apps where citizens report potholes, litter, graffiti.
Yeah, I use that sometimes.
Right. Now, those aren't estimating tools directly, obviously, but they represent this environment where real-time, super granular data about city infrastructure, services, resource use, that data can start informing maintenance schedules, urban planning, how resources get allocated, and that in turn is going to influence future construction projects and their costs in profound ways.
So hang on, the insights from something like an Internet of Trash, using GPS tags on bins to see where waste goes, find inefficiencies that could kind of weirdly inform how we budget for future city projects, or even design new waste plants or plan their maintenance.
Conceptually, yes, absolutely. It's a great example. These things illustrate a future where this accelerating diffusion of technology into urban space could give us an unprecedented understanding of systems and generate data to optimize the entire system, even in real time. So this broad context, it just points to an increasingly data-driven, connected future for the estimator. Their skill will be in integrating and interpreting these new dynamic data streams, moving beyond just static plans to estimates that are almost alive, informed by how things are actually performing out in the real world. It adds yet another layer of science to what they do. 4, the art of judgment. Risk, market conditions, and human factors.
Okay, so it's definitely far more than just adding up numbers or plugging things into a BIM model, no matter how smart that model is. It sounds like there's this whole other side involving uncertainty, judgment calls, navigating subjective stuff. That must be where the art of estimating really comes into play, right?
You've absolutely nailed it. That's a crucial distinction. Estimators are constantly managing assumptions and constraints. They're related, but different. An assumption is something they take as true, but without absolute proof. They have to make a judgment call based on the info they have, past experience, market trends, like assuming a certain material price will hold steady for 3 months.
Okay.
A constraint, though, that limits their options, like a hard budget cap from the client or a deadline that just can't move. Project management best practices even suggest keeping an assumption log to track all these things for transparency, accountability, knowing the basis of the estimate.
Right.
And it's about viewing those assumptions realistically, not being too idealistic because, over-optimism can be really dangerous in estimating. And this pragmatic view leads towards something called probabilistic estimating, which is a fancy way of saying you develop a range of estimates with probabilities attached. Like, okay, there's a 50% chance it costs X, but a 90% chance it won't go over Y.
So acknowledging the uncertainty.
Exactly. It admits that absolute certainty is rare in big, complex projects. It gives decision makers a more realistic financial landscape to work with.
And risk identification, you mentioned that. That's going to be huge in construction. Weather, material shortages, subcontractor issues. Our sources really stress how vital that is for the estimator.
Hugely important. Risk identification is the methodical process, right? Evaluating the project, recognizing potential risks, scope risks, cost risks, schedule risks. And it's not just a quick chat. It involves using checklists, surveys with experienced pros, audit forms to document potential pitfalls. For instance, just consider that a contractor's bid might only be valid for, say, 30 to 60 days.
Right, not very long.
No. And in that short window between submitting the bid and maybe getting the contract, the market could go wild. Material prices could jump. Skilled labor could suddenly get scarce. The estimator has to anticipate that possibility, build in some contingency. It's this ongoing dynamic risk assessment.
So what does all that mean when a contractor is actually putting together the bid they hope wins the job? It sounds less like pure calculation and more like, I don't know, a strategic gamble, an educated guess about what might happen.
It's definitely more than just adding up the materials on the plans. It's about proactively thinking about market swings for specific stuff. Like the sources mention oolitic slates, expensive to dig and prepare. You need to know that. Or, just as critical, the availability and cost of specialized labor. The sources say maybe not many men now with sufficient skill exist for certain traditional tasks, like laying stone roofs a certain way. That scarcity drives up costs, slows things down. There's even a great historical example in the sources, the shift from a local Swiftland slate to mass-produced Welsh product because of the Industrial Revolution.
Oh, interesting.
Yeah, it perfectly shows how big market forces, technology, changes in labor skills can totally change the cost and viability of using certain materials. Estimators have to constantly adapt, find alternatives, factor in these outside pressures.
It reminds me of that phrase we heard in one source, a contractor telling an owner, if it's fat in some places, it may be thin in others, talking about their bid margins. That's not just about the numbers, is it? It's strategic pricing. Understanding the client, the competition, maybe taking a calculated risk on one part of the job to be competitive, hoping to make it up somewhere else. That's the art of the deal, really.
Absolutely. It's the art of the deal, underpinned by the science of the estimate. That's a perfect way to put it.
And this blend of art and science, it also seems to pop up in that classic tension in construction. The ideal of perfect craftsmanship versus the hard realities of budgets and schedules. How do estimators handle that?
Yeah, it's a real tension. There's a great anecdote in the sources that captures it beautifully. You have this carpenter, super meticulous, worrying over a tiny fraction of an inch, like a 32nd of an inch.
Right.
And someone more practical says, look, it won't show, it won't make any difference here. But the carpenter replies, it doesn't matter if it doesn't show, it ought to be right.
Wow, that says a lot.
It really does. It highlights that deep divide between the craftsman's ideal of perfection and the pragmatic need for speed and cost control on a commercial job.
But sometimes, despite wanting it perfect, the budget or the schedule just forces compromises, doesn't it? The source talks about two carpenters having to cover up the space where Bill has dreamed long and hard of pilasters, those decorative columns, because it was a contract job. They had to ditch an aesthetic detail for the bottom line.
Exactly. And the estimator's role in this is crucial. They have to balance those often qualitative, desire-specific looks, levels of finish with the hard, quantifiable costs, and what's actually buildable within the time and budget. This is where that art comes in again. It goes way beyond just calculating. It's about really understanding the drawings, knowing what the builder can actually do well, what the market is for special skills or materials, and crucially, what the client really prioritizes. Is speed number one? Is it the absolute lowest cost? Or is it getting that unique design feature no matter what? The estimator helps translate those abstract priorities into a realistic budget, and sometimes, they have to be the one to say that dream detail might need to change.
It almost reminds me of those historical descriptions of architects needing to represent it to himself in imagination or foresee in execution how a corner of a building will actually look and feel going beyond just the lines on the paper.
Yeah.
They had to mentally build it first.
That's a fantastic connection, and it perfectly captures the estimator's challenge, too. They have to visualize the entire construction process just from the drawings, build it in their head step by step. They need to foresee potential site logistic problems, spot opportunities for savings through clever material choices or construction methods, understand the real-world implications of every design choice. Even ancient writers like Vitruvius talked about understanding material properties, how travertine splits and cracks to pieces at once in fire. An estimator today might not quote Vitruvius, but they have to implicitly understand and cost for those kinds of material risks and how they perform under stress. It's this vast body of knowledge, often learned through years of hard experience.
Okay, in a field this complex, juggling materials, engineering, volatile markets, human expectations, leadership, and really clear communication must be absolutely critical, especially for the estimator who's trying to tie it all together financially.
You are absolutely right. Effective leadership promotes project success, the sources say. It's not just about managing tasks. It's about creating an ethical and adaptable environment where people feel they can contribute, where problems can be discussed openly. And the estimator is often in this really pivotal spot. They have to facilitate communication between all these different specialists, architects focused on design, engineers on structure, subcontractors on their specific trade. And each group often has, as Peter Drucker put it, their own knowledge, his own logic, and his own language.
Right, speaking different dialects almost.
Exactly. And the estimator often has to be the translator, making sure everyone understands the cost implications of what they do and how their piece fits into the bigger financial puzzle.
So the estimator isn't just stuck in a silo crunching numbers alone. They're like a key node in this huge communication network, trying to get everyone on the same financial page, understanding the budget and what's possible within it.
Absolutely. Because knowledge is most valuable when understood and applied, right? And getting multiple perspectives always strengthens the understanding, strengthens the estimate. This collaboration is crucial for refining the numbers, sorting out discrepancies when people interpret plans differently, and just managing everyone's expectations from the client right down to the subs. A well-communicated, transparent estimate builds trust. And trust is essential for things to go smoothly. 5. The high-pressure scramble. Bid day dynamics.
Okay, now let's talk about the climax, the grand finale of the estimating process where everything converges under maximum pressure. The bid day scramble. That sounds intense. What actually happens? Why is it such a critical, crazy event?
Yeah, it is pretty much exactly as chaotic as it sounds. It's this high-pressure, often frantic period where the estimator and their team have this very short window, often just hours, sometimes minutes, to pull together all the final quotes from potentially dozens of subcontractors, suppliers, their own internal costs, into one single coherent competitive price for the client. And it often comes right down to the wire, the last moments before the bid deadline.
Wow.
Our sources describe that whole pre-construction phase, which leads up to this bid, as often being fast and furious because of schedule constraints. So estimators are constantly under intense pressure, rapid calculations, double-checking figures, making quick, critical judgment calls, all while managing this flood of last-minute numbers coming in.
The stakes must be huge.
Incredibly high. A mistake, an inaccurate bid can cost a company millions, either by losing the job or winning it and losing money.
So given that crazy tight timeline and all the info hitting them at once, what does that mean for how the project gets structured overall?
It sounds like planning for the scramble is almost as vital as the numbers themselves. It means planning has to be incredibly dynamic. It's not a one-and-done thing you do at the start. As one source puts it, planning is dynamic and does not end until the project is completed. This ongoing planning directly feeds into how ready you are for bid day. And it also highlights something crucial, involving those who will directly supervise or perform the work being planned.
Getting the actual builders involved early.
Yes. Getting project managers, superintendents, foremen involved in the planning leads to better plans and greater ability to adapt plans when needed. On bid day, that translates into having a team that's ready to integrate last-minute info, make quick judgments because they deeply understand the practicalities of the work being proposed. It makes the final bid much more robust, more realistic. It's about being prepared for the unpredictable nature of it all.
This whole high-stakes environment, all these moving parts, external bids flying in, it sounds like a complex system just waiting for a bottleneck, doesn't it? Like one delay, one missing quote could just derail the whole thing.
It absolutely is. And that concept of bottlenecks is really relevant here. Our sources use manufacturing analogies. The goal in a system like that is to keep the bottlenecks busy, to maximize throughput, which in business terms is the rate the system generates money, or in this case, produces a winning bid.
Okay.
The estimator is, in a way, forecasting that financial throughput. How efficiently can this project turn resources into the final product? If a critical subs bid is late or a key material quote is missing, boom, that's the bottleneck for the entire bid package. The estimator's job is to spot those choke points early and manage them proactively, keep everything flowing towards that deadline.
So to manage those bottlenecks, get the bid out on time,
Yeah.
even if it means, like the source said, breaking all the rules sometimes.
Yeah.
Deviating from the standard process to keep things moving during that scramble. Is that what has to happen?
Well, the sources interestingly suggest that if the rules had to be broken to hit the main goal, then maybe they weren't good rules to begin with, especially if they're actively hindering the project objective.
Ah, interesting perspective.
Yeah. And this applies directly to the critical path, that sequence of tasks that dictates the project's overall duration. If a critical activity has been started late, a setback is likely. On bid day, this means making those real-time, pragmatic calls to overcome whatever constraint is threatening getting that bid submitted on time, complete, and competitive. It just highlights the dynamic, sometimes improvisational nature of managing these pressure cookers. The ultimate goal, a successful bid, has to take priority.
You know, to help you, our listener, picture this. Imagine that scout troop trying to hike 10 miles in 5 hours. If the slowest scout, let's call him Herbie, is holding everyone back, you can't just let the fast ones disappear over the horizon, right? The solution, as one source points out, is you stop the fast ones, keep everyone together, and actively manage the bottleneck Herbie, so the whole system, the whole troop, makes progress together. That's kind of the estimator's challenge on bid day. Coordinating dozens of subcontractor bids, each like a scout, making sure the whole project bid moves forward together, on time, dealing with any slow points immediately.
That's a great analogy.
So, with all these individual quotes flooding in from countless subs and suppliers, how do estimators actually manage all that engagement? How do they integrate it all into a reliable, coherent final bid? Sounds like a logistical beast.
It's definitely complex, but there is a structured process, usually starting well before bid day itself. It begins with pre-qualifying bidders, making sure they're capable, financially stable, then sending out formal bid notifications, often holding pre-bid conferences to clarify the scope, answer questions.
Okay.
And that all leads towards doing thorough bid analyses and recommendations, and eventually preparing the contracts. A really key part of this is something called commitment planning. This involves tasks being negotiated between immediate requester and performer using reliable promising. And those promises, crucially, come with clear conditions of satisfaction, things like when will it be done? How much will be paid? What quality standards? This structured approach is vital for gathering solid, reliable data for the estimate.
So the estimator isn't just sitting there passively collecting numbers. They're actively managing relationships, negotiating, setting clear expectations with all these different trade partners, almost like conducting an orchestra, making sure everyone plays their part correctly for the final performance.
Absolutely. That's a fantastic way to think about it. It goes way beyond just adding up numbers. The estimator is deeply involved in fostering workflow reliability, which is often measured by something called PPC, plan complete.
We have PPC.
Yeah, if PPC is always low, meaning subs aren't reliably hitting their targets, it actually discourages the site supervisors from putting effort into planning because they figure the work won't be ready anyway.
Vicious cycle.
Exactly. An estimator influences that reliability by making sure the bids and schedules they accept from subs are realistic and achievable in the first place. It builds trust, increases the odds of success once the project actually starts. Their ability to communicate clearly, negotiate fairly, anticipate problems.
Yeah.
That's just as important as their skill with spreadsheets. Outro.
Well, we have certainly journeyed through the intricate and clearly very demanding world of construction estimating, a profession that, as we've really seen, demands both the precision of science and those nuanced, almost intuitive insights of art. From understanding the tiny details in a work breakdown structure, counting every nail and beam, to navigating that dynamic, high-pressure, big-day scramble where it all comes together, you hopefully now have a much clearer, deeper sense of how these huge projects get priced and planned. The construction estimator, they truly are the financial gatekeeper of this whole industry, this crucial figure blending data, deep experience, expert judgment, all to craft that project budget. Their work, as our sources really powerfully emphasize, is the absolute foundation, the foundation upon which every single financially successful construction project is built. So what does all this mean for you, our curious listener? Well, I think it means appreciating the immense, often invisible skill that's required. The skill to foresee the challenges, the opportunities hidden within just a set of drawings. Whether it's for a small home renovation or some massive public works project, it's really a testament to human foresight and strategic thinking.
Yeah, and it leads us to, I think, a really fascinating question for you to chew on after this deep dive. In this world that's just getting richer and richer with data, more connected, where digital tools like BIM promise ever greater precision, automation, real-time optimization of costs and schedules, how will that irreplaceable human art, the art of understanding unspoken risks, anticipating tricky market conditions, navigating the subtleties of craftsmanship, balancing those qualitative desires against hard costs, how will that art continue to evolve, adapt, and ultimately define the estimator's essential, truly indispensable role in the future?